Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October November 2023 paper 2. In today's lesson, we will talk about electricity and waves. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these questions. Let's study together, let's improve together. Total time for this exam is 1 hour and 30 minutes. You need to answer all questions in this paper and total mark for this paper is 80. Question 1 says the formula for a diffraction grating in the list of equations is n lambda is equal to d times sine of theta. Which of the following quantities does not have units? So if you look at these quantities, first of all we have n, so we need to understand what n is representing. N is representing fringe order and this is just number and this has no units. So we can say n has no units. Lambda is the wavelength, so the unit of this one is meter, means the SI unit for this one is meter. And then we have d, this is slit separation. So we can say this is slit separation, this is just distance and the unit of this one is meter. And then we have theta, unit of this one is radian, or we can say unit of this one is degree. So radian or degrees we can use. Now the question is that what is unit of sine of theta? You can think about this one, give it some time and tell me what is unit of sine theta. Try first of all by yourself. I hope you will come up with this answer. It has no unit. This is dimensionless. Why it is dimensionless and how we can prove this is dimensionless? If you look at this given equation, n lambda, this is equal to d sine of theta. This is homogeneous equation. Homogeneous equation. It means that units on both sides are the same. So here we have unit on left side, that is meter, because n has no units and this has unit meter. So it means sine of theta is also dimensionless. So very important, next time they can ask you what is unit of sine of theta. Now if you go to these given options, the answer for this question has to be A, because n has no units. I hope this makes sense to you. If it makes sense to you, why sine of theta has no unit, why this is dimensionless, please like and subscribe because your encouragement is very important. If these videos are helping, like and subscribe because that is your encouragement for your teacher. More you appreciate the work, your teacher will be able to support you more and will be able to help you more. So please like and subscribe. Second question says the current potential difference graph for a diode is shown in the figure. Which of the following statements is correct for this diode? So there are few points we need to understand before we answer this question. If you have understanding of those points, it's wonderful. If you don't have, listen carefully. So first thing we need to understand, in this direction, means to the right, we call this is forward biased. Forward direction you can say, or simply you can say this is forward biased, in forward direction, and this is reverse biased. So these terms are very important. So we can say to the left is reverse biased. Now if we sketch a circuit, so simply we can draw a circuit like this. We can attach one safety resistor. So this one is the safety resistor. Always when we connect a diode in the circuit, we always connect one safety resistor. So this is one very simple circuit. So in this case you can see this is the positive terminal of the battery and this is positive side of the diode, this is negative terminal of the battery and this is negative side of diode, or you can say negative terminal of diode. So when we connect diode in the circuit, so this is how we need to connect in forward biased. So this is what we will say is forward biased. So this one is forward biased. we can also connect this one in reverse bias. So again we can connect one safety resistor here, and we can connect our diode in this direction. So we can connect like this. So this is our diode. In this case, you can see the positive is connected with negative, and the negative of this diode is connected with positive. So this is in reverse biased. This is safety resistor. So this is forward bias and this is reverse biased. So these are some basic points you need to understand about diode. Now if you look at given options, it is given to us this diode does not conduct in the reverse direction, means in this direction. But if you look at this figure, we can see there is small current in this direction, and also there is a potential difference. So it's telling us does not conduct means no current flow, but in this case we have small amount of current. So simply you need to read this graph. So it means this option is not correct. The resistance of this diode in reverse direction is infinite, but actually it's not infinite because there is small current here. So if resistance is infinite, it means that V over I means I has to be equal to 0, then R will be infinite. If R is infinite, so let me write down, if R is infinite, then at any value of V, I has to be equal to 0. But in this case we have some value of I, so it means resistance is not infinite. So option B is also incorrect. The resistance of this diode decreases when the PD is above 0.7 volts. 0.7 volts, and 0.7 volts as special name. We call this is threshold voltage. So it has special name. After that we can see current increase rapidly. It means resistance decrease rapidly. Current increase rapidly and resistance decrease also rapidly, because I is equal to V by R. If this increases rapidly, this has to decrease rapidly. So it means decreases when the PD is above. Yes, after this resistance is decreasing. Let's say first of all we look at the resistance at this point, so I can draw this dotted line here, and then I can look at resistance at this point. For that purpose I also need to draw another dotted line. So I can draw the line from here. If you look at the gradient of these two lines, gradient for the red line, you can see this is steeper, then this one is shallower. So what does it mean? Resistance in this case, the resistance in this case is equal to, we can say resistance is equal to 1 over gradient. Resistance is equal to 1 over gradient, because gradient is equal to I over V and resistance is 1 over gradient. Mean this is V over I. So if this gradient is steeper, it means resistance will be lower. Mean if this one is higher, this one will be lower, and vice versa is also true. So we can say resistance is decreasing after 0.7 volts. So the answer for this question is C. This diode does not conduct when the PD is below 0.7 volts. We have some value of current here. It means current can flow. So this is also not possible. So like this you need to understand. These are some beautiful points about diode. So these things should be very clear in your mind. Question 3 says, which of the following would increase the detail in an ultrasound scan? Means how we can get more details. So simply we can write down more details. More details are possible if we use higher frequency ultrasound waves. If frequency is higher, so we will get higher resolution image. High resolution image means that we will get more details. Now the question is that why we have to use the higher frequency. If the frequency is higher, lambda will be shorter, and if the lambda is shorter, it means objects size, so smaller objects in size can be seen if the lambda is shorter. Lambda, because when lambda becomes equal to object size, diffraction takes place. Diffraction takes place means significant diffraction takes place. Significant diffraction. If there is a significant diffraction, it will not be easy to see the image, or it will not be easy to get a clear image of the object due to diffraction. So there is a limitation on image resolution that depends on frequency used to create an image and size of the object. So when lambda wavelength of ultrasound waves is about equal to object size, then it becomes hard to get a clear image due to diffraction. So for more details, we have to use higher frequency ultrasound waves. Now if you look at given options, this is telling us increasing the duration of the pulses. Actually this will reduce the details, so this is not possible. Increasing the frequency of the ultrasound, yes, this will increase resolution, so this is possible answer. Increasing the intensity of the ultrasound waves, increasing the intensity, it will have no effect on details, so we can say this is also not possible. Increasing the wavelength, so this means frequency go down, so the resolution will go down, means detail will be reduced, so this is also not possible. So these are the points you need to understand about ultrasound. Question 4 says, in a current carrying copper wire, the drift velocity of the electrons is very small. Which of the following best explains this? For this question, simply we need to understand transport equation. So we can write down first of all transport equation. Transport equation simply tells us that current in a conductor, this is equal to NQVA. For this question, we need to explain why V is small, means V is the drift velocity. So we can make V the subject, so we can say V is equal to I over NQA. So V has to be small. V will be small if current is small, or V will be small if N is very large, if Q means the charge on single charge carrier, mean on each electron, if this is very large, or if A is very large. So for this question, if you look at given options, we can see in option A, it is given to us the charge on an electron is very small. If this charge will be small, this will be very large, so it means this is not possible. Cross-sectional area of the wire is very small. If this one is very small, V will be very large, so this is also not possible. The current in the wire is very large. If current is large, it means V will be large, so this is also not possible. The number of electrons per unit volume of the copper is very large, so N is the number density. So if N is large, this will be small, so you need to understand N is the number density. So these terms are very important. You need to understand the names of them. Number density simply is the number of charge carriers per unit volume. Number of charge carriers, simply you can say number of electrons, free electrons, number of charge carriers per unit volume. So this is N, means N is number density. So the answer for this question has to be D. So D is the correct answer. Question 5 says the graph shows how displacement varies with time for a particular point. Means we are talking about one point only as a wave passes. What exactly it means for a particular point? It means that if I look at this point all the time. So when time t is equal to 0, then time will be equal to 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, like that. So at this point, how I will see the motion of the particle, this is how the motion of the particle will look like. Means the particle will go up, particle will go down. In this case, it doesn't mean it will go up or it will go down. It means that displacement will increase. Displacement can increase along vertical. Displacement can also increase along horizontal. So it means that if I'm looking at this particle all the time, I will see particle displacement is increasing, then decreasing, it become negative, and increase in magnitude, and then decrease in magnitude, increase in magnitude, decrease in magnitude, all the time. So it means that this wave, this graph, it can represent transverse wave, and also it can represent longitudinal wave. Understanding is very important. You need to visualize. Each word in the question has certain meaning in physics, so you need to understand that. So this can represent transverse wave, it can also represent longitudinal wave. Now we need to understand which statement is not correct. So here we have time. So we have time on x-axis, means we can find the time period. So from here we can find out time period. Option is said the time period can be determined directly from the graph. Yes, this is correct. This statement is correct, but this is not correct answer. The wavelength can be determined directly from the graph. Wavelength we cannot determine because x-axis is time, so we can determine time. So it means this statement is incorrect. So the answer for this question has to be B. The wave could be longitudinal. Yes, it is possible. So this is true. The wave could be transverse. Yes, this is also possible. So the answer for this question is B. I hope you understand what this question is telling you. This question is telling you for a particular point as a wave passes. If I'm looking all the time at this particle, I will see displacement of particle will increase, then decrease, then increase, then decrease, and so on. So that's the reason it can represent transverse wave, and also it can represent longitudinal waves. I hope this one is clear to you. If this was helpful, please like and subscribe, because it's very important that you appreciate the work of your teacher. In this universe, nothing is free. If you get something free, it means it's not good for you, because then you will be addicted and you will not use your abilities in the right way. So in this universe is all about give and take. Always we transfer, means we convert energy from one form into another form. As a human beings, we also work as a machine. We take certain type of energy, means we take in chemical energy, we convert into sound, we convert into heat, and mechanical energy means we work in different forms of energy. So in this universe, remember, nothing is free. It's all about give and take. Give and take. Question 6 says the length of the string Vy is 0.6 meters. Which of the following is the wavelength of the standing wave? Wavelength. So first thing we need to understand the distance between two consecutive nodes. So here we can mark here. So this point is called node. This is also node. So this is node, and this point is also node. So you need to understand the distance between any two consecutive nodes is lambda by 2, and this point we call this is antinode, and this point is also antinode, means the displacement is maximum. So this point is also antinode. And also the distance between any two consecutive antinodes, this distance is also equal to lambda by 2. So we can simply say the distance between these two is lambda by 2, and distance between these two nodes, this is also lambda by 2, and distance between these two consecutive nodes, this is also lambda by 2. And this total distance means the length of the string, this is equal to 0.6 meters. So the length of the string we can also say is equal to 3 times lambda by 2, and this is equal to 0.6 meters. So from here we can say lambda, this will be equal to 2 times 0.6 divided by 3. So we can find out value of lambda. So if we divide this one by 3, we will get this one is 0.2, and we multiply 0.2 with 2, we will get this is 0.4 meters. So the wavelength is 0.4 meters. So this is how you can answer. And so the main concept is that you need to understand the distance between any two consecutive nodes is lambda by 2, and also the distance between any two consecutive antinodes is also equal to lambda by 2. You can also understand the distance between node and antinode is lambda by 4. Maybe for some questions this understanding is very important. Question 7 says, which of the following sections of the string would be in phase with each other? So we have to look at these sections. We have section 1 here, we have the second section, we have the third section. In this section, if I look at this point, let's say this point is moving down, means this particle is moving down. It has this certain amplitude, so we can also draw the line here. So it's very important to understand in a beautiful way. So I can clear this ink. So we have one particle, imagine that at this point the amplitude of this particle will be this, and particle here, its amplitude will be this much, and amplitude of this one will be this one, and this particle will be at rest all the time. And particle here, it will have this much amplitude, and this will be the amplitude of this one, and this one has very small amplitude, and this particle always will be at rest. Now if you look at the second loop and we look at the particles, if you look at this particle will be moving up with this amplitude. This particle also will be moving up, this particle will be moving up, and this particle also. So actually the amplitude of this you can just extend to this point. So this is the amplitude from the equilibrium. So you can also simply draw this arrow like this. So this arrow has to be like this arrow has to be like this. And if I take any particle here, the amplitude will be equal to this much. Amplitude of this one will be equal to this, amplitude of this one will be equal to this, and amplitude of this one will be equal to this. And if I look at particle at this point, this particle will be moving down, this particle also will be moving down, this particle will be moving down, this particle will be at rest all the time. This particle will be moving down, this particle will be moving down. Now if you look at these arrows, this is telling us when this particle start moving down, at the same time this particle also will start moving down. And when this particle will complete one cycle, this particle also will complete one cycle. So it means this particle and this particle, they are always in phase. And if I look at this particle and this particle, these two particles also will be always in phase. So it means the particles in section VW and particles in section XW, always they will be in phase. So we can simply say these two sections, the particles in these two sections always will be in phase. But if we compare these two sections, I mean these particles always they will be in anti-phase. It means that when this particle will move from this point, it is moving up, and this particle is moving down, so the phase difference is equal to 180 degrees. So these two particles always will be moving in opposite directions. Means phase difference is 180 degrees, it means moving in opposite directions. Means when this particle will move from this point to this point, always will be moving down, and this particle will be always moving up until this. Then it will start moving down, this will start moving up, and so on. So it will be this kind of motion, like this, like this, like this, like this. So VW and XW, they will be in phase. VW and XW, so this is not possible answer. VW and WX, they will be in antiphase. So like this you need to understand, we can say antiphase, so this is not possible. VW, WX, WX and XY, these two particles in these two sections, they also will be in antiphase, so we can say antiphase. So this is also antiphase. Like this you need to understand, antiphase. So it means this is also not possible answer. VW and XW, so VW and we have XY, they are in phase, so this is the answer. No sections are in phase, so this is also incorrect. So the answer for this question is C. Question 8 says, a string is placed under tension capital T. A wave travels along the string. A second string has the same mass but twice the length. A wave travels along this string with the same velocity as the wave in the first string. Which of the following is the tension in the second string? So we need to find out tension. But we need to understand speed of wave in a string is equal to tension over mu, means the mass per unit length. So we can write down this is T, and here we have mass per unit length. So if we rearrange this one, we can say this is T, L divided by capital M. So we can simply say V is equal to TL divided by capital M square root of this. If we square both sides, we can say V square. This will be equal to TL divided by M. For this question, it is given to us speed is the same in these two strings. They have the same speed. Wave has the same speed in these two strings. So it means this quantity is the same. And total mass is also the same. So simply we can say V square times M. This is equal to T times L. So we can say this one is constant. A beautiful way means a systematic approach. So this means that T1, L1, this has to be equal to T2, L2. So we need to find out tension in the second string. So we need to find out T2. We can say this is equal to T1, L1 divided by L2. T1 is equal to capital T, and we can say L1 is equal to capital L, and L2 is 2 times L. So from here we can simply cancel this L with this one. So we got new value of T, that is equal to T by 2. T by 2. So the answer for this question is C. So this is in a systematic way you can answer. I use this approach because this technique is very helpful. A lot of questions in physics, tricky questions, you can answer with this technique. Question 9 says the diagram shows some of the energy levels for a hydrogen atom. Which of the following expression is equal to the lowest frequency of light possible from a transition between these energy levels? Lowest frequency. So we need to understand how energy change is linked with frequency. So this is energy change. From here we can say frequency is equal to energy change divided by Planck's constant. This is a constant, so if this energy is the smallest, this frequency will be the lowest. Now we need to look at energy changes. So we can imagine electron here when it jump from this energy level to this energy level. So the energy change means the energy of the emitted photon, that will be equal to delta E1. Let's say that is delta E1, and this one will be equal to minus 1.36 minus 0, so it means energy change is minus 1.36 times 10 to minus 19 joules. So we can say this is multiplied by 10 to minus 19 joules because this factor is here. Now we can also consider the second. So in this case, if electron jump from this energy level to this one, we can say energy change will be equal to delta E2, and delta E2 will be equal to 2.42 times 10 to minus 19 minus we have 1.36. So you need to understand this is also minus times 10 to minus 19. So in this case we have negative 2.42 times 10 to negative 19 plus we have 1.36 times 10 to minus 19 joules. So this is energy difference. If we solve this one, actually we will get in this case 1.06 times 10 to minus 19. Actually I'm just writing these things in detail to explain you in a better way. So we got negative number. This is negative. Negative simply means that energy in this case is emitted, means the energy of electron has been decreased. So that's the reason we have negative sign here. But this question is simply asking us about the frequency. So don't worry about negative sign. There is no negative frequency. So this sign you can ignore. And for the last, when electron jump from this energy level to this one, let's say electron jump here, so we can also calculate delta E3. So we have negative 5.42 times we have 10 to minus 19 minus into minus we have, that is 2.42 times 10 to minus 19. So in this case, if you solve, you will also get negative sign. So it means that energy of electron has been decreased. Energy has been decreased. So we will also get negative answer, that will be equal to 3.0 times 10 to minus 19 joules. But for this question we need to calculate frequency, smallest frequency, lowest frequency. So smallest energy change means we have to take this energy change, or simply you can say delta E2. The same thing you have to just rewrite here. So we have negative 2.42 times we have 10 to minus 19 plus, I'm just writing this again, so we have 1.36 times 10 to minus 19, and this is divided by Planck's constant 6.63 times 10 to negative 34. So this is our final answer. So this is the answer. So if you look at given options, you can see this one is the right answer. We need to find the energy change, the difference, energy change difference. So the final answer you will get is negative, but frequency cannot be negative. So it simply tells us energy has been decreased, energy of the electron has been decreased. So we can write down in this form. But maybe you will be confused. Oh, I don't see the negative. Why negative sign is not? Because this is just talking about energy change. So if I do this one, I will get answer in this case minus 1.06, and this is divided by 6.63 times 10 to minus 34. This negative sign simply tells us energy of electron has been decreased. So I can also write down simply this one. Let me write down here. So I can say this is equal to 1.06 times 10 to minus 19, because this factor is there. So this is 10 to minus 19 divided by Planck's constant. We have 6.63 times 10 to minus 34. So you can ignore this negative sign, because this simply tells you decrease in energy of electron. So you can ignore. So that's the reason they have ignored. They have written the energy change. So that's the reason you don't see negative sign here. So don't get confused with this one. This simply tells you energy of electron has been decreased when it jump from this energy level to this one. So the answer for this question is D. Question 10 says two photographs X and Y were taken of the same car windscreen. Photograph Y was taken through a polarizing filter. Which row of the table is correct? So first of all, if you look at photograph X and if you look at photograph Y, you can see in photograph Y, we can see inside the car, but in photograph X, we cannot see inside the car. So first of all, you need to figure out why this is the case, why we cannot see inside the car in photograph X. So this is the first thing you need to understand, and this is due to the light. When the light reaches the windscreen, when it reaches the windscreen, so this is the boundary between windscreen and air. So there is change in medium, so some of the light will be reflected, some of the light will be transmitted, mean it will be refracted. So this is you need to understand. So here we are using polarizing filter, so we can say we are using polarizing filter here. We also need to understand what will happen to the transmitted light and what will happen to reflected light. So these points we need to understand. Let me explain you this one with the help of this diagram. In this diagram you can see we have incident light. When it reaches this boundary, means boundary between air and windscreen, some of the light is reflected, some of the light is transmitted. And this incident light, this is unpolarized, mean it can oscillate in any possible direction. So this is unpolarized. So this is the first thing you need to understand. Incident light is coming from sun, so this is unpolarized. And this one is partially polarized. I hope you understand what is the difference between unpolarized light and partially polarized light. Very important point, I will explain you after a while. First of all, we will just answer this question. And if this angle is 90 degrees, mean angle between reflected light and transmitted light, refracted light, if this angle is 90 degrees, this is actually called Brewster angle. So angle of incidence, this angle we call is Brewster angle. So this is angle of incidence, this angle is Brewster angle. So this is after the scientist who discovered this phenomenon. So this is Brewster angle. If this angle is 90, this angle we call is Brewster angle. And this light then, this will be horizontally polarized. So this light will be horizontally polarized. So we can say this will be horizontally polarized. So this one is polarized, this is partially polarized, and this one is unpolarized. Now if you look at given options, I hope now simply you can find out light transmitted through the windscreen, mean this light transmitted through the windscreen, this light is partially polarized, or simply you can say this is unpolarized. This is close to unpolarized light, because this is oscillating in more than one directions. So we can say this is close to unpolarized light. But there is difference between unpolarized light and partially polarized light. I will explain you that point very soon. Because this is not plane polarized, because this light is not oscillating in one plane only. This is oscillating in more than one planes. So we can say this is still unpolarized. So the answer can be C or answer can be D. And reflected light, this is plane polarized. So the answer for this question has to be C, because this is horizontally polarized, mean this can only oscillate along horizontal. So this is plane polarized, but this is not plane polarized. So this is close to unpolarized light. So the answer for this question is C. Let's try to understand what is difference between unpolarized light and partially polarized light. I will explain you in a very brief way. So first of all, you can simply imagine we have light that is unpolarized. So simply you can imagine, so this light, this is representing unpolarized light, mean light can oscillate in all possible planes, in all possible directions. So this is unpolarized light. And in front of this unpolarized light, if we place a filter, let's say this filter we place, so this is transmission axis of this filter, and then we rotate this filter by angle of 90 degrees. So now it is horizontal. So in this case, at any angle, the intensity we will receive, that will be I naught by 2. The intensity of unpolarized light is I naught, and we will receive intensity. If this light is unpolarized, it doesn't matter whatever is the angle of polarizing filter, always we will get I naught by 2. So it means this is unpolarized light. Simply we can check with the filter. Now if we have partially polarized light, so let me draw here. So let's say this light, this is representing partially polarized light. Partially polarized light. Let's say the intensity of this one is I naught, and in front of this one again, if we place this filter, so let's say this is vertical polarizer, if we place in front of this one, and then we rotate the angle of this vertical polarizer by 90 degrees, mean we rotate this one by 90 degrees. Now it is like this. So I hope you will get the idea. It is like this. So in this case, we will receive light sometimes with maximum intensity, mean intensity will be higher, and sometimes we will see the minimum intensity. It means that at different angles, intensity of transmitted light will be different. So it means this light is partially polarized. So that's the difference. We can check with filter. Now about polarizing glasses. As this light is horizontally polarized, I hope you will say we have to use vertically polarized glasses so we can stop, so we can avoid glare. So we have to use polarizing glasses with vertical transmission axis. I mean, this is, I hope you can see here, we have with vertical transmission axis this. So you can see this is vertical, transmission axis are vertical because this light is horizontally polarized. To block this light or to avoid glare, we have to use glasses with vertical transmission axis. That's all for this video. I hope you have better understanding of polarization now. If this video was helpful, as always, please like and subscribe. And if you want to support the channel, join Patreon, and also if you need more help, you can leave your questions in comments. You can ask me questions anytime. And also, if you're looking for resources, you can join Patreon, because on Patreon I upload more resources.